Alright, for video 4 we have to create a balanced chemical equation. So we have aluminum and hydrochloric acid, so I'm going to write aluminum and hydrochloric acid. And I know that hydrochloric acid and aluminum undergo a simple substitution reaction, so I'm going to have hydrogen gas and aluminum chloride. Now, I know that aluminum has a positive 3 charge and chlorine has a negative 1 charge, so I'm going to crisscross them, and I need aluminum chloride to have 3 chlorines for every 1 aluminum. So there we are, and I know that hydrogen does not exist as H alone, and it is H2. It's a diatomic molecule. So I need to have this thing balanced. It's not balanced currently, so I'm going to have aluminum, hydrogen, and chlorine. So on this side I have 1 aluminum, 1 hydrogen, 1 chlorine. On this side I have 1 aluminum, 2 hydrogens, 3 chlorines. I know that 2 and 3 can only meet at 6, so then I need to make this a 2. So now I have 6 chlorines, and I have 2 aluminums on this side. I need to make this a 3. So now I have 6 hydrogens. Well, that's very easy because now I have 6 and 6 on this side, and I can just put a big 6 right there. Coefficient of 6 changes that up, and they're both 6 now. And then I can put a coefficient of 2 for aluminum. Now I have 2. Now I have a balanced chemical equation for aluminum and hydrochloric acid. The next one is a potassium hydroxide and sulfuric acid. So I have potassium hydroxide, which is KOH, and I am adding that to sulfuric acid, my favorite acid, H2SO4, and I am going to make water because I have an acid and a base, and acid and bases make water. I'm also going to make potassium sulfate and 2H2O. I'm going to put a 2 right there, and I'm just going to check. It's a lot easier for me to just give you what it is going to become. Okay. I'm going to keep H, O, and SO4. So I have 2, 4 H's and 1 SO4 and 2 O's. And on this side I have 1 SO4, 2 K's, 4 H's, and 2 O's. Bam! It's balanced. It's 2 and 2. I just gave you that as a freebie. Alright, the next one is a solution has a hydrogen ion concentration of 1 times 10 to the negative 5 molar. It's asking me what is its OH concentration. It's asking me what is the pH, and it's asking me what the pOH is. So I'm going to skip the first one just because I am going to skip it. So I know that to find the pH, I can use my periodic table, and the table gives me an equation, and my equation is right here. Okay. I can actually just not skip the first one, and the equation is right there because I have H and it wants me to find OH. So it says that Kw is equal to H plus multiplied by OH negative. I don't know what Kw is because I am a poor student and I did not learn that because my teacher's not very good. So I'm going to look at my constants, and I see Kw is the ionization constant of water, which is 1 times 10 to the negative 14. What? That's crazy. It's like the answer's right in front of you. 1.00 times 10 to the negative 14 is equal to 1.00 times 10 to the negative 5, and we have OH negative. So what I'm going to do is I'm just actually going to divide by this 1.00 times 10 to the negative 5 on both sides. So two things, I can do it in the calculator, which is a fine thing to do. clear that. So I have 1.00 times 10 to the negative 14, right? And I'm going to divide this by 1.00 times 10 to the negative 5. That's going to give me 1.00 times 10 to the negative 9. That is my OH negative. And I can also say that because I have exponents and they are of the same base, I can just say negative 14 minus a negative 5, negative 14 minus negative 5 equals negative 9. And because they're both ones, it's just 1 times 10 to negative 9. Alright, so that's my OH negative. Alright, so now what is my pH? Well, I'm awful at doing pH, but I do know that I can just look it up. So how do I find pH? Well, pH is negative log of my hydrogen ion concentration. So I'm going to do pH is equal to negative log of my H plus. And I know what my H plus is because the problem has given it to me. So I'm going to, in this calculator, go to catalog and go to log. That's how I find it here. I need a negative log, and it's 1 times 10 to the negative 5. So my pH is a 5. And that makes sense because it's an acid. So pH is equal to 5. And to find pOH, I need to remember that 14 is equal to pH and pOH. So I have 14. I've already used up 5 of them. So 14 minus 5 equal 9. So my pOH is equal to 9. I can also notice that because it's a 1 times 10 to the negative something, the way logs work is this something is what the pH will be, and because I have the pOH, the same thing will occur. Alright.